Hello friends, this video is on Join Skew in Spark. We'll understand why one key can slow down the entire cluster. So let's get started. As we know, Spark is designed for massive parallelism. But sometimes one single key can slow down the entire cluster. Today, we'll understand why that happens and, more importantly, how to recognize it. So Spark divides data in partitions. Each partition becomes one task. Each task runs on an executor. Parallelism works only when partitions are balanced. If one partition is much larger than the other, parallelism breaks. Spark is not slow, but unbalanced partitions are. Now the question arises, what is join skew? So join skew happens when one join key appears far more frequently than the others. That key causes one partition to receive significantly more data than the others. During a join, Spark groups rows by key. So all rows for the same key must go to the same partition. So if one key appears millions of times, that partition becomes very large. So that imbalance is called join skew. This is not statistical skew. This is partition imbalance during a shuffle. So why joins make it worse? Let's understand what happens during a join. Spark hash partitions data by join key. Rows with the same key go to the same partition. So if one key dominates the dataset, that partition becomes massive. Now one task now takes longer time and works harder than the others. The entire stage waits for it. So one bad key can freeze your parallelism. Now let's understand with a real world example. Imagine an e-commerce system. Most customers place one or two orders. But one corporate account places millions. So you join orders with customer data. All rows for that corporate ID land in one partition. That partition becomes huge. So other executors finish early and one executor keeps running. This is what skew is. So if you open Spark UI, you will see many tasks. Most finish quickly. One task runs much longer. So the entire stage waits for that task. Why? Because Spark waits for the slowest task to finish. So skew is visible in the task timeline. So why repartition does not fix the skew? This is a common mistake that people increase partitions. They use repartition, but repartition still uses hash partitioning. So it's using the same key, same hash, same partition. So dominant keys remain dominant. You increase partition, but the heavy key still goes to one place. So in short, repartition only changes count. It does not change key dominance. Again, there is another question that arises: why more executors do not help here? Let's understand this. The, another common reaction that people do is scale hardware, add more executors. But Spark assigns partition to executors. So if one partition is huge, one executor becomes the bottleneck. So other executors sit idle. So executors process partitions, not individual rows. That's why we need to understand that more machines does not fix skew. Now, before we talk about solutions, let's clarify something. So, data skew means uneven distribution of data across partitions. And join skew is a form of data skew that occurs during a shuffle join. So, skew can also occur in aggregation and group by. So, in short, join skew is a specific case of data skew. Now, we need to understand how to handle join queue. This is very important. How do we fix queue? So there are several strategies. First is key salting, where we split heavy keys into multiple subkeys. Again, we can also use broadcast join, where we avoid shuffle when possible. There's a third one, pre-aggregation, where the data is reduced before joining. Fourth is adaptive query execution. So Spark 3 introduced AQE. AQE can detect and split skewed shuffle partitions. So we can handle skew, and skew must be handled deliberately. So if this question appears in an interview, say this, that join skew occurs when one key dominates the dataset, causing partition imbalance. And it happens during shuffle. So the stage slows down, but Spark waits for the longest task. That answer shows that you understand the execution internals. So Spark is a distributed engine. It's a powerful one, but it is sensitive to data distribution. So if you understand skew, you understand the real Spark performance. So hope you find this useful. And let's see Let's meet in the next video. Thanks for watching.